I think Baker has at least this information up. We know there's this, we looked at the additional risers. Todd has the second quote. So we're comparing, I think, Gus's quote versus another quote. But I think there's some additional items. I think that's what you have so far. And then I think there's some additional things that have come up that they just wanted to bring up. So, okay.
So Gus has another idea that should help us address this ongoing issue and these ongoing concerns of the piping deteriorating because of the soil here and the age of the piping. So we're concerned that this is going to be an ongoing issue, not only for these two risers plus the third riser, that we have a leak that we haven't found yet. So Gus has come up with an option to resolve these concerns, and I'll let him walk you through that. Go ahead, Gus.
Who is on the phone right now?
Todd and Todd.
Todd and
Todd Baker.
And Carlos?
And Carlos.
Okay, so in looking at the problems that we're having here so far today, going back to, we'll go just a quick paintbrush of what's occurred in the past. In Hangar A, Hangar 1, you had an underground break. That break was constituted by a hole in the pipe. And that hole, as far as I know, was from the outside in. And it was quite a significant hole. It wiped out quite a bit of material around and under that floor. That was Hangar A. The next one that I was involved in was Hangar E, and in that material there, the problem, it wasn't with the piping, it was with the fittings underneath the slab. It could have very well been the piping itself or the interface connection between the elbow and that pipe. In either case, we had a significant leak there that transpired. We couldn't dig underneath the building with retrospect of creating a disturbance or putting the building at risk from a structural standpoint. So the piping was cut short, approximately 20 feet away from the building. A new line was run in, a new section of line, and the riser came up outside the building, and then we went in and abandoned that piping that was underneath the building. The next one that we found is in Hangar C and D. Those,
which are the two we're addressing right now.
Those are the two that are unresolved at this point. We've identified the leak between the main shutoff valve on the outside of the building and the riser, which comes up through the slab approximately 2 to 3 feet inside the wall. And how we did that was we shut the PIV off on the outside and captured the pressure between that PIV and the riser on the inside. On Hangar C, the most easterly riser, we lose 100 pounds of pressure in that riser within 20 minutes. On Hangar D, that is real easy to find because what we've got is a small fountain of, looks like a miniature Old Faithful bubbling up through the slab right at the riser. So we're definitely know that those two are cut and defined. The third thing that we did is we isolated all the risers and wanted to see if perhaps we had something else occurring in the loop. So we isolated all 7 risers and we checked all the risers themselves, again, between the PIV and the riser inside. And the other 5 remaining risers seemed to be holding without any problems. Then we locked the pressure in the entire loop that goes on the inside of C and D, and we isolated that pressure in there with sectional valves. You have 2 sectional valves. We closed the one on the northeast corner of that would be the northeast corner of Hangar C and the street connection, and we locked 100 psi into that loop. We kept that water in, we kept that 100 psi in that loop for approximately 1.5 to 2 hours, and then when we opened one of these PIVs that we knew wasn't leaking, we lost approximately 35 psi in that loop. And that's a significant amount of water, because that loop is in itself almost 1,000 feet of 8-inch pipe. So there is another leak in there, and we pretty much have resolved that it's in the piping that constitutes the 8-inch loop that goes in between those buildings. So right now, the known factors are we have 2 risers that we are definitely know that there's leaks in, and that's one in C and one in D. But we also, through our due diligence, have found out that there is another leak, and for the most part, I feel pretty confident that it's in the 8-inch piping in the loop itself. It could very well be in one of these PIVs. It could be a PIV that's leaking a little bit and allowing it to go in. And if that's the case, then we have another riser under the slab that's leaking. But I feel pretty confident that it's in the 8-inch piping. Now, how we would resolve and find that would be a difficult task, because we'd have to pothole down to that main for the entire length. Probably that main is 6.5 to 7 feet in depth. We'd have to pothole about every 20 feet, remove a 2 by 2 foot piece of asphalt and pothole those areas and see where we get some water. Somewheres along that main, there's going to be a reservoir of underground water that's going to show up in one of these potholes. And then from that point, you'd have to dig in the direction that the water's flowing into the hole and hopefully find the leak in that main. But it's a difficult task to do. It's labor intensive, and you still could end up, that water takes the path of least resistance. Unfortunately, normally a lot of times it'll travel underneath the underside of the piping. If there's any soil that hasn't been compacted properly underneath, that water will transmit itself to the underside, and it could travel 40 or 50 feet and then finally resurface. So that being said, I just wanted to kind of reiterate the fact of what we've got going on C and D. So based on that,
Hey, Gus?
yeah.
Hey guys, just to stop just real quick. So just to kind of, because we're a little bit trying to figure out from where we started from and where we are today. I'm showing, Susan, we had hangar C and D. We showed one of the 3 risers leaking in hangar C. In hangar D, we had 2 of the 4 that were leaking, and based off those 3 risers that were leaking, we had the AR of 112,000. Is that right?
No.
No, that's not correct. We have 2 that are leaking, 1 in C, 1 in D, and then the third one was between C and D. We weren't sure where that one was, and we only had 16 hours allotted in that 111,000 for investigations.
So it sounds like there's more to the AR than what originally was submitted, right?
Yes, we've always mentioned the third leak, which was the unknown. So we did disclose that will cost more money if we go down the route that Gus is discussing in regards to opening up the ground for the third leak. The 2 we know for sure where they are. The third one we're not sure where exactly it is underground, but it is the 8-inch wall from his experience.
If this wasn't, if you didn't have an asphalted ramp or plain storage area, what we would normally, the consensus for finding this leak would be hook a high pressure pump to the main, start pumping it, and as you lost pressure, you would just keep pumping it until the water surfaced on top. And then at that point, you dig down and find it. Unfortunately, because you've got a completely asphalted apron here, we can't do that. The only way, and then the other thing that occurs when you do that is you put that main under such significant pressure. Normally we would pump this thing up to 150 pounds minimum, and hoping to expedite and find that leak. In this case, where everything is completely asphalted and you just can't take the risk, I wouldn't personally want to take the risk and pump that up and then end up having something blow out underneath one of those other buildings again, or adjacent to one of those other buildings, and have that water continually run there because it is asphalted for a long duration, and then you really create a mess, not only from a standpoint of having to dig and muck all that out, but you could put undue stress or civil engineering stress on that structure. So that being said, I kind of looked at this thing and said, you know, if it was my facility and I knew that I had this thing that was occurring because it's deterioration of the materials, because of you've got some really hot soils in the area, and that can be verified because of Hangar E. That system and that system let go there, and that system is 10 years old. Mm-hmm. So I don't know exactly when A let go, but I think the system was significantly older than 10 years old.
Yeah.
Yeah, it was closer to 25 years old.
Mm-hmm.
But you're going to continually see this problem keep occurring. And the fire department has even mentioned it. When I was there meeting with them last week, he even mentioned that there's other facilities in this area around the airport that are having to deal with this problem right now on systems that are 25 to 35 years old. So it's not something that they're not aware of.
So what's the recommendation, I guess?
What I looked at it, and the recommendation would be to bring in a new underground between C and D that's classified as HDPE. It's a highly corrosive resistant material that's utilized a lot in the oil field industry, but there are some manufacturers that have it approved for fire protection use. And all of that material is electronically fused together, so there's no metallic parts in the ground except for one riser when you come up. And then we would bring that riser in between C and D, and then once we got to building C and to building D, we would come up outside of the building, not bringing that material underneath the slab, but come out outside of the building, then go into the building, and then run a new 8 or 10 inch main on the inside of the building at a high elevation and run it the entire east-west direction in both hangars. And then once we got to the existing riser, drop down and reconnect to that bottom of the riser. In essence, in Hangar D, you would have 4 reconnection points. In Hangar C, you would have 3 reconnection points. And then at that point, everything's above ground. You're not disturbing your parking area or your tarmac area. And then that existing piping would be cut off at the floor and put a blind flange on it. And then that piping would be decommissioned in place and slurry filled. I ran it by the fire department. The fire department said that he has no problem with doing that as long as the hydraulic calculations met the existing. And we're pretty confident that that can be done. The work would be done. It could be done during the day. It's at the entrance to each of the hangars. It's above the retractable doors, so it's not in any area that I don't think it'd be the area that would be least disruptive to your normal everyday traffic pattern as far as bringing planes in or out. Or if there was a given area, like Tim said, and we discussed briefly, if for some reason planes had to come in and out, it isn't that difficult to move a forklift, a scissors lift, a 30-foot scissors lift out of the way while that aircraft is removed, and then continue on the work. But it's on the edge of each hangar in B and C. Again, what it does allow you to do is do this work in the fashion that's least disruptive to your everyday traffic, and there's no trenching or digging of the asphalt parking lot. The PIVs, the existing PIVs, would be removed, and then the depression capped, and then the existing main would be evacuated from all water and then slurry filled with concrete so it doesn't cavitate. And then the control valves for the systems still come out through the wall as they do in hangars E or the south hangar, where you have a control valve that's mounted on the wall on the outside. So that would address C and D. Hangar A, we looked at that, and the same thing could be done there. We have another connection for hangar B, for hangar A, which would be in front of hangar B. That also is only about a 20-foot run to bring it up and into the building. That would be HDPE. It'd come into the hangar and supply the 2 foam risers above at the ceiling level and drop down, protect those 2, and then we just more or less took a general walk today. That riser, that supply going to hangar A, could also be brought up in the corner of hangar B, which would be aesthetically would be it's the least aesthetic, gives you the least amount of aesthetic problems, brought up in the corner, and then follow up on the roof, follow your wall, your mansard wall all the way around till they got to hangar A, and then run into the bay in hangar A from up above. All that piping would be completely hidden from view except one little segment that comes out of the hangar at the first level in hangar B and jumps up and goes into the mansard area. So
why are we doing A? What's our concern of A?
That's the same issue.
It's the same issue
The
as all of
underground
this.
piping?
It's all
Right.
this
But
here.
we don't
main-
have any leaks or anything
Not yet,
at this
no.
point.
No,
Except for the main that ruptured in 3
except
years
for
ago.
this one right here.
So
Right.
we could theoretically do C and D at one point and then do A at another phase, correct?
Yeah,
Okay. Because right now the pressing issue is C and D.
C and D, yes.
Correct.
And the main.
So
exactly.
now when you come up in C and D, how come you can't just tie into the riser? Why do we have to do all the overhead stuff?
Because you have to get back to that. Each riser has an alarm valve, and it has to be fed separately from the underside of that alarm valve, because in each case that alarm valve has a separate foam interface with the foam components that are attached specifically right there at each riser. So you just can't tie into it above. You have to drop down and come through the flow pattern, which is on the underside of the alarm valve.
Okay. I'm not really sure, but Dave's shaking his head. So
No, it makes sense.
Has a flapper in there.
Remember the
Also
flaps that
a
kind of
one-way
set off
valve,
the system?
So the pressure's being
you'll have to
pushed
show
out.
me that. But
Yes,
I get it in
But with
theory.
Gus's approach, doing above ground eliminates all the underground issues. It addresses the main and the risers. And Gus, correct me if I'm wrong, talking to the fire marshal, he also said that this is not considered a permit.
He stated that under the conditions that we have here, which are deterioration of underground mains, which are present and evidently occurring with some regularity. He said that he would consider this as a maintenance issue. Maintenance issues, as far as he's concerned, in the state and San Jose City, do not require a permit. The only thing he stipulated was if this was done, he would want to make sure that the hydraulic calculations for each of the zones is adequately addressed as far as the 1986 criteria.
Mm-hmm.
Because if we end up pulling a permit, he said what would end up happening is the city engineers would probably mandate that the systems be updated to the 2015 standards in NFPA. And if that were the case, then it would be a real cost impact to you folks, because first of all, you're on a dead end main, you've got very poor water, and you'd end up with systems in essence that would be the size of what you have in E-Hanger right now.
When you say very poor water pressure,
Water pressure and water availability, GPM. You're on the end. This
very
main is a dead end,
right?
and you happen to be the last customer on it. So what you've got is 100 pounds of pressure, but you've only got about 1,600 GPM at 30 psi. When another 300 feet down the road here, where Signature is, and their new connections, they have 100 psi main that delivers them 6,000 gallons a minute at 30 psi. So in essence, if the same criteria that they utilize today for Signature, if that was brought on to this facility, the only way that you could be able to deliver this would be to increase the size of this main and put a fire pump in.
Wow.
So right now we're budgeted to repair 2 or 3, right?
Two. And investigate.
And how much is that?
111.
$111,000.
Worst case scenario. Yes. Best case scenario,
So-
95.
Okay.
98.
Can I summarize the dollars just to make sure that I've got the right information?
Sure.
I've got 111,000 just to repair 2 risers. That would not fix the third leak.
Correct.
And we went to James with that information. He said, let's get a quote on doing all 10 risers.
Correct.
So even with the 10 riser quote, we came in at 499,800.
Correct.
10 risers, still not knowing where that third water leak was, because it could be in a main, which we weren't addressing a main at that point.
Correct.
Correct.
We did advise that the mains would be a separate project.
Now
Right.
keep
So even
now.
the 499.8 would not have completed the job, so to speak.
Correct. Yes.
Now keep in mind
Now we
that
come in at 896,014. That gives us all risers, so there'll be 11 because you have the additional one in the parking lot, plus all 3 mains, eliminating the leak of the chance of there being a leak anywhere in the system, because basically that's a complete system repipe.
Above ground. Yes.
yes.
That's how I understand it. That's for the whole facility.
Yes.
We're covered.
For risers and
For
main.
risers and mains.
Main.
Not the piping. That's another.
Not the piping in the hangers,
Right.
correct.
Right. Risers and
But
main.
we don't have any
Especially
other
after 2011.
underground
No,
issues.
all this underground main would be abandoned. The one thing though that I just want to make sure everybody is aware of, when we tested C and D, what we didn't do, Carlos, is we didn't cut. We had that sectional valve beside C completely closed, but what we didn't do is secure the sectional control valve in front of B and see if we had any pressure loss in that leg of the piping, which there could very well be, but we don't know at this point. You know,
And
that's,
that would be between 2 PIVs, or would that be a section between the PIV and the main?
it'd be between the main PIV shutoff and approximately, I think there was about 1,000 feet of 8-inch pipe that we didn't physically put a 2-hour test on with just city pressure to see if there was an additional leak in that segment of the piping. We focused on C and D, but we really didn't look at A at all.
Okay. Okay, so for this 896,000 to do all risers and all mains, how can we break that up into smaller packages, so to speak? Can we do C and D as one phase, A as another phase, and the mains as a third phase, or how would we?
You'd have
Be able to
you could do B and C. I mean C and D as one phase, and then you could do B as one phase, and then address A as another phase.
So, hey guys, I think we need to know the pricing to do that in phases. This project keeps growing and growing and growing. So if we could have that in our pocket to take to James, I guess my other question is, in doing it in phases, how much of that is mobilization, and how much does that add to the project if we do this in 3 phases as opposed to 1?
How long a span of time would you be talking about between the phases? I mean, you'd get one done, and then you're going to wait till a year and start the next one, and a year later do the next one?
Probably, because we
If I had
can
to
budget
guess,
that way.
We would do C and D now. We would do maybe B at the end of the year, toward the end of the year, and then the third phase sometime in 17, if I had to guess.
Because normally in this industry, we budget from a material standpoint, and overall the normal increase on a yearly basis is anywhere from 3 to 7%. So per year.
Okay.
So if you had to break it down, can you right now, or you need to work on that?
We could break it down pretty quick.
We could get something to you probably tomorrow.
Okay. And then will the fire marshal allow us to phase it out that long in length? Like, let's say every quarter, or if not, like
We'd
how
have
long
to
would you-
ask him.
Okay, because like he'll be like, no, you can't wait more than 6 months. You have to start the next phase within a certain.
Well,
amount.
the
Well,
thing
since
that
it's repair, I would think you would be fine with that.
I think he would too.
Yeah.
Keeping in mind that when you're doing C and D, that you're not completely knocking out anything with A and B.
Right.
You know, they're still remaining.
Yeah, we have
Fully
exposure there.
operational.
Yeah, they're fully
Yeah.
up-
Right.
We have exposure because there's still
Right.
underground piping.
Right. So the buildings are situated so you could do C and D first, and then you could do actually B and then A. But keeping in mind that the connection, the underground connection for A and B come off the same supply.
I think that's going to be easier to sell to James, doing it in phases like this. I think it's smart to do C and D and get rid of this underground problem that's going to keep haunting us if we don't do this. But I think we're going to have to sell it to James, so to say, in phases.
No.
So a couple of things. Is the 111, is that above ground solution, or is that fixing the existing piping in place?
Underground.
Underground. So, I mean, I thought the whole phase approach was to put everything above ground.
Right. So that's the concern was if we go the route of above ground, then we're wasting money doing underground. If we then eventually do everything above ground, then it's 111 wasted.
Gus just came up
Right,
with this
that's
idea late last week.
Yeah, just
Of
after
we had already discussed the underground fix,
underground, then the 10 risers,
and then the 10 risers,
then the
and then
mains.
Gus was thinking about this, and he said, this is going to be an ongoing problem. Let me think about it. He came up with the option of abandoning the underground and going above.
With the fire marshal's blessing.
Right.
Because that was all ultimately up to the fire marshal.
So the 111,000 AR probably is a worthless AR right now if we're going to go on the state's approach because we want everything to be above ground. So we need a quote for above ground C and D, right?
Yes. and they said they could get us that tomorrow.
All right, so I mean, let's do this in phased approach. But again, I would like to see what the total project's going to be, because I know there's mobilization with each one of these phases we do, which adds to the cost. So if we got to remobilize 2 more times.
Yeah, we sent it this
What was
morning.
that?
The total cost of, we do all of them right now, is $898, I believe.
There was some contingency in there, so more like 900 something.
900.
But I heard somebody say that's without piping. I heard somebody say
No,
No?
that's turnkey.
that's everything. Okay.
That including alarm and detection.
Yeah. So, and I can forward that to you. I know Carlos has it in his office now.
Yeah, you sent me.
I don't know if
Sorry.
Carlos, you have the capability of forwarding that, but
Yeah, I forwarded the proposals to Todd.
okay. So that was from this morning.
All right.
And that was just everything.
Yeah.
That wasn't in phases. So if we do it in phases, I'm sure, like Gus
Right.
mentioned, it'll adjust the cost if we do it over a period of time.
Yeah, let's see what that looks like, I guess, and then we can take both approaches to James.
Okay.
All right.
Is there any way to make the